Alright, so we're working in 3-6. As you know the drill by now. Let's go and do the warm-up and then check your answers. Okay, so here we go. So here we're just asking you to substitute the given values of mx and y into the equation y equals mx plus b. If you don't know this equation, you should, but it is slope-intercept form. We'll talk about that in this lesson. So we're just going to plug these in and solve for b. So y is 0, it's our first number here, so it's going to go 0 equals mx, so m is 2, x is 3, and then we're going to solve for b. So this is 0 equals 6 plus b, subtract 6 from both sides, and we're going to get negative 6 equals b. So that's number 1, b is negative 6. Now, we'll give ourselves some space up here for number 2. In this case, y is negative 4, so negative 4 equals mx, so negative 1 times 5, plus b. So that's going to be negative 4 equals negative 5 plus b. And to solve for b, we're just going to add 5 to both sides. So 1 equals b. So just plug in and solve. Now the next two that we'll be doing, I'll try to get another color here. That's what I'm doing. Okay, so we're going to solve these for y. This first one is pretty quick. You just add 6x to both sides. Now, if you remember from up above, I was kind of talking about this slope-intercept form. When I write this out, I'm going to always be putting that x term first. So that's going to be the 6x. So this would be 6x plus 9, because that would give you, not that 9 plus 6x isn't slope-intercept form, but you're used to seeing the x in front, so that's what I like to stick with. Alright, number 4, we're going to do a couple steps here. To get y by itself, we need to move the 4x and then the minus 2. So to move the 4x, we're going to subtract 4x from both sides. As I said before, I'll do it over here, this would be negative 2y. Let's put the x in front. So negative 4x plus 8. So to solve this for y, we're going to divide everything by negative 2. So y equals, it's the only thing left on the left-hand side, negative 4 over negative 2 is positive 2x, and then 8, positive 8, over negative 2 is minus 4. So obviously we're going to be doing a lot of that in this lesson, so hopefully this is something that makes sense to you. This is Algebra 1. Really, this whole lesson is Algebra 1, honestly. Alright, so here we go. We are in 3-6 learning about lines in the coordinate plane. Obviously you can get ideas about graphing lines in the coordinate plane. So our objective is to graph lines and write their equations in slope-intercept form and point-slope form. We also need to be able to find and classify parallel, intersecting, or coinciding lines. Hopefully you know parallel, intersecting. Coinciding are pretty much the same lines. That's all that means. Okay, so let's move on and do that. Alright, so the equation of a line can be written in many different forms. The point-slope form and slope-intercept forms of a line are equivalent. It means they're the same. I mean, it's just another way of writing it. It just depends on what you solve for. Because the slope of a vertical line is undefined, these forms cannot be used to write the equation of a vertical line. Remember, that's that x equals a number. So to summarize everything that we're going to be reviewing today, let's go ahead and write these down now so we have them. We have slope-intercept form. And slope-intercept form is this. It's y equals mx plus b. And if you remember right, this m is going to be your slope. And again, what you're doing is you're multiplying the input, which makes your output bigger or smaller depending on what m is. So the bigger or smaller that m is, the bigger or smaller your y will become. So it affects how fast or how slow your graph changes. B is going to be your y-intercept. And your y-intercept is always going to be when x is 0. So it's 0 comma b. If you think about it, if you plug in 0 for x, then 0 times m is 0, and then y is always going to be equal to the constant, which is b. So that's your slope-intercept form. That's the most common one, honestly. The other one you're going to see, and we'll talk about it, is we'll get to point-slope form. So we got slope-intercept form. The other one, which isn't really in the objectives here, but I'm going to talk about it anyway, is standard form. And standard, it's supposed to be a D, it's an ugly D. Standard form is AX plus BY equals C. And this is really good for finding the x and y intercepts of a line. I'll give you a quick example since we really don't do much of it in this lesson. If I had 2x minus 4y equals 8. This is really good at finding the x-intercept, which is x is 0, and the y-intercept, which is 0y. Because if you plug in 0 into your standard form, it's going to get rid of one of your terms altogether. So this would be 2x minus 4 times 0, which is gone, equals 8. So 2 times 4 equals 8. So we have 4, 0. Over here I have 0 for x, so I'd have 2 times 0 minus 4y equals 8. Again, that's gone. So negative 4y equals 8. So y would have to be, if you don't see it, negative 2, but I'll divide. Y is negative 2. So 0, negative 2. It's just plotting points. And if you had these points on a graph, you'd have your 4, 0, you'd have your 0, negative 2, and you can draw your line pretty quick. So that's what standard form is all about. Again, it's not really covered much in this lesson. It's more about slope-intercept form and point-slope form, but I want to make mention of it. Alright, but here's point-slope form. Alright, point-slope form is, well, let's start by writing it. It's y minus y1 equals mx minus x1. And it's used when you are given a point, which is x1, y1, and a slope, which is m. Well, this one, it's easier for me to explain as we go through our examples, but that's point-slope form, which we will be using. And it's, another way you can write it is like this. If I took this y1 and I moved it over here, this is another way of writing this. If I can erase that, okay. So I could also write it as y equals m x minus x1. Actually, I want to get rid of the x1. Sorry. Y times x minus h plus k. And this is when you're given the point h, k, and the slope m. And this is the way I actually teach this when I do my SAT class, because that's the way they teach it on the SAT. But it's also useful, and it's one of these things where when you go in Algebra 2, I kind of know what you're going to be doing in Algebra 2. You're going to be learning about translations of functions. And point-slope form is basically a translation of functions. So I'm going to try to show you this method because honestly, this is more useful for you moving forward than the standard point-slope form that you're supposed to learn in Algebra 1 and we're supposed to repeat to you in geometry. However, I know better, and when you're in Algebra 2, you're going to want to know about this h and k notation. It means the same thing as x1 and plus y1. It's the same thing. They're constants. Okay? A lot of times you see x1, y1, you think they're variables, but they're actually constants. It's the point that you're given. And you'll see that as I do the examples. Okay, so there's your point-slope form, slope-intercept form. I already wrote those out. Now I talked about this in the last lesson. Your vertical lines are x equals, your horizontal lines are y equals. If you want to go ahead and write those again, you can. Or if you didn't write them last time, shame on you, but go ahead and write them now. Okay? These are our special lines. Alright. And I already talked about this when I did the example of the standard form. A line with a y-intercept, b, contains this point. This is a y-intercept. And an x-intercept, the y value is 0. So like again, remember, if you're on the x-axis, that's going to be a comma 0. Key here is the 0 because you're on the x-axis, you're not going up or down. And here, this would be like a 0 comma b. Emphasis on the 0 for the x value. That never changes. Obviously the a and b are just numbers, they can be anything, but the x-axis is always going to have a y value of 0, and the y-axis will always have an x value of 0. Alright, so the first example, again, we have, we'll do a lot of these actually in this lesson, so the examples will change the information we're given, but the question is mostly the same. We're going to write the equation of each line in the given form. So this one we are using point slope form. So in point slope form, you're given a point and a slope, as you can see. I'm given the slope of 6, and I'm given a point of 3, -4. So I'm going to show you obviously the way they want you to learn, because you need to know it because that's the way you're going to be seeing it. So in this case we would have x1, y1. You can also call it h comma k. I want to show that off to the side, but again, the way you're going to see in the book, it's written as x1, y1, where x1 is 3 and y1 is -4. So as I write this out, we're going to have again y minus y1 equals m x minus x1. And as I write this out, again, just plug in the numbers. Y minus y1, which is -4, equals, here we're going to have the slope is 6, so that's 6, x minus x1, so minus 3. This becomes y plus 4 equals 6, x minus 3. There's your point slope form. Just plug it in. Now the way you'll see it as you move forward in if you start doing translations, if I do the y equals m x minus h plus k, again k is -4, so this would just be y equals, the slope is 6, so 6, this is still x minus 3, x minus h, but it's plus k, so it's plus -4, so minus 4. Again, it all means the same thing, it's just the way it's worded and the way the k is moved over, the y1 is moved over, so it's still set equal to y. There's your equation. Pretty simple if you're given the right information. We'll talk about graphing it in just a minute, but we've got to get the equations first. Okay, same thing, we're going to write the equation of the line, but now we're going to use slope-intercept form. So in slope-intercept form, that's going to be y equals mx plus b. So I need to have the slope first. Let's just go ahead and do that. So we're going to find the slope, and we're going to go find the slope doing for what we learned in 3.5. I'm going to subtract my y values. Again, x1, y1, x2, y2. So we're going to go y2 minus y1, 2 minus 0, over x2 minus x1. So 1 minus -1. So that's 2, and then 1 minus a negative is plus 1, so 2 over 2 is 1. So that's my slope, or m. Now, this point, I'm going to pick a point. This is what we did in our warm-up. We have a point. I'm going to use the point -1, 0. That's my x and my y. And I'm going to take this point and this slope, and I'm going to plug it into my equation and solve for b. Again, if you are wondering what we're doing, I need to find the y-intercept to finish this equation. So I have a point. I actually have 2 points. I picked the -1, 0 because I felt like it. But I'm going to plug that point in, plug in my slope, and solve for b, my last or my final remaining constant. So y is going to be 0 in this case. My m is 1 times x, which is -1, plus b. So 0 equals -1 plus b. Add 1 to both sides to solve, and b is equal to 1. So if you got your important points here, we have 1 and 1 for both of them. So your equation is going to be y equals 1x, or you can just say x plus 1. So that's slope-intercept form. We should be able to kind of do both depending on what scenario we're dealing with. Okay, now let's start graphing. So this first graph that we're going to do is going to be a graph in slope-intercept form. So if we're doing a slope-intercept form graph, here are the steps that we're going to take. Step 1, we're going to plot the y-intercept. Step 2, we're going to use the slope to find the second point. Step 3, we're going to draw the line. Yes, this is that simple. It's 3 quick steps. Okay, so let's do it. Start with your XY axis. And I'm going to plot, and it looks like I'm going to go out like 4, just to have space here. Okay. So let's plot the y-intercept. Now the y-intercept in this case, if you look at it, is b equals 1. So 0, 1. So I'm going to plot that point. 0, 1. Now I'm going to do my rise of my run. My slope equals 1/2. So that's my rise, and 2 is my run. So I'm going to plot that by doing rise. So I'm going to go up 1. And I'm going to run 1, 2. So again, I'm going to rise 1, run 2, and plot that point. So now make sure we label these points. When I'm grading this, I do need to see these points, otherwise you can kind of guesstimate your answers without actually knowing what you're doing, and I'm not going to let you do that. So you must label your points. When graphing lines. Okay, so in this case I'm going to label the point 0, 1, and that other point looks like it's at 2, 2. Common mistake people make when they screw these up, they just say, oh, well that's, you know, rise is your y values, so, and run is your x values, so, oh, that's at 2, 1. No, this is not a point. These are like directions to your next point. The directions don't equal your point, so don't do that. Once you do rise over run, look and see where you're at in the xy plane and label that point. And then you can connect your points from there. And there we go. Okay, so that's a graph of your line in slope-intercept form. Alright, now we're in point-slope form. Now again, the thing that I like to do, I'm just going to keep doing it no matter what, is I'm going to move this 3 over. We are in point-slope form, I'm just going to move it over here. So y equals -2 x plus 4 plus 3. Okay, so this is point-slope form. Our point, remember, is h comma k. So in this case we need to see what is h. Now normally, let's remember how this works, it's y equals m x minus h plus k. If I have minus h, that means I'm at positive h. So the way to remember this, let me move this out of the way actually. You're going to want to know this because it's going to be the same for every function you'll ever learn for the rest of your life. The term inside the parentheses here, the h, if you have a minus h, you're going to go right h. Plus h means we're going left h. It's opposite. That's how we'll sum that up. Okay, now if you're looking at k, if it's plus k, you're going to go up k. If it's minus k, you are going to go down k. And these are not opposite. I can probably explain that in class if you'd like me to. Just remind me as I'm going through the notes. make a little note of it now, and I'll explain why one's opposite and the other's not. But I really need to kind of show you that. It's a little easier to do that in class and on a video. So anyway, what we're going to do at this point, we're going to find this HK, and in this case HK, it looks like we're going to be, because it's plus 4, or plus 4, it's always opposite, so it's going to be negative 4, and the plus 3 means it's at positive 3. So negative 4, positive 3 is our point. Remember, this is opposite, this is not. Our slope, that's just going to be rise over run, so let's put a 1 under the negative 2, and we should be able to graph this. So we'll do our XY axis. And it looks like I'm going to go out 4. So if you go negative 4, 3, so negative 4, 1, 2, 3, label that point. I'll just do it in black here, that's fine. Negative 4, 3, and then from there, I'm going to use my rise over run. I want to find my next point. I'm going to go down 1, 2, so it puts me down at 1, and then I'm going to go right 1. So that's going to give you your second point. Actually, yeah, I'll do that. And then again, where am I? Looks like I'm going 1, 2, 3, negative 3, and up 1. Okay, that's my slope, and connect your points, and you got your line. And that is graphing using point slope form. Alright, next one, this should be pretty simple if you know your special lines. Again, we went over this last lesson. So this is one of your special lines. This is a horizontal line. You need to just know this. If you have to reason it out, you're wasting time. Honestly, it's so common. So if you're at y equals negative 3, you're just going to go down negative 3. And this is the only one I don't really need a point labeled on because it's just horizontal. It's pretty straightforward. But again, if you were labeling points, this would be 1, negative 3. This point over here would be negative 2, negative 3. This point over here would be 4, negative 3. Hopefully you see a trend, because there is a trend. Your y value on the horizontal line is always negative 3. That's kind of why the equation is y equals negative 3. That's your y value every time. Okay, but we should know that now. Y equals a number is horizontal at that number. Next up, let's do another point slope form graph. Let's just do the actual graph of it. So in this case, we're going to just add 1 real quick to both sides. So y equals negative 2/3 x plus 2 plus 1. So we'll go through this one a little bit faster now. We got a point, which is HK, and that's now, remember, these are opposites for H, so that'll be negative 2. This is not opposite with the plus 1, so positive 1, so that's your point. Your slope is negative 2/3. So let's graph this one quickly. I want to go out, looks like the 3, that's good. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, let's try a different color here. Back to orange. So I'm going to label my point negative 2, 1. So negative 2 up 1. Label it. And I'm going to go down, using my slope, down 2, right 3. Negative 2 over 3. So I'll try to keep this in orange here. So down 1, 2, and then right 1, 2, 3. So that's your next point. Looks like I'm at 1, negative 1. And draw your line. hopefully straighter than mine, because mine's not straight. So again, I'm trying to get the point across that once you get this process down, you should be able to graph these lines really, really fast. Okay. Okay. So getting into some of the other types of equations, I was talking about coinciding lines, parallel lines, intersecting lines, things like that. I remember a system of two linear equations and two variables represents two different lines, and they can be either parallel, intersecting, or coinciding. Parallel means they don't touch. Coinciding means they always touch because they are the same line. But they can also just intersect. And again, we got the different forms, so you may see one in standard form, one in point-slope form, one in slope-intercept form. But again, we can graph all sorts of lines. I'll explain how we approach those as we get to our examples. Okay, so your parallel lines, again, those are the ones that have the same slope. So those are some examples of parallel lines. Notice you have a 5x and a 5x. Again, the key here, though, is the y-intercept. For them to be parallel, those y-intercepts have to be different, because if they were the same, they would be coinciding lines like I have over here, where the y-intercepts are actually equal. So just having the same slope doesn't make it parallel. They have to have the same slope but a different y-intercept. Intersecting lines just have different slopes. Again, if they're opposite reciprocals, we know that they intersect at a right angle because they're perpendicular. But again, if they have different slopes, they will eventually touch. Okay, so in this case, we only need a graph. We're just going to determine whether the lines are parallel, intersect, or coincide. So as we look, let's check out first our slopes, because that can tell it most of the story right there. These have different slopes. They look the same at first, but they're not, because one's positive, one's negative. So this means they intersect. Again, at this point, they can't be the same equation because they don't have the same slope. If they're coinciding, everything's the same. So as soon as I know the slope is different, I know the lines are not going to be coinciding. So that makes it pretty quick. Alright, next up, I have one equation that's in slope-intercept form, but this one's not, and I can't see the slopes, compare them without solving this for y. So let's do that. Let's get it into slope-intercept form by dividing everything by 6. So this would be y equals negative 2 over 6 is negative 1/3 x. 12 over 6 is plus 2. So in this case, it looks like I have the same slope. So I have the same slope, which is negative 1/3, and I do have a different y-intercepts. If I have the same slope and different y-intercepts, these are going to be parallel. Remember, if they had the same y-intercept, they'd be coinciding, but they don't. One is at 5, one's at 2. So parallel lines. Alright, next up we have a standard form equation and a point-slope form equation. So that's the same thing here. We need to go ahead and solve both of these for y, so we can see, which situation we have here. So I'm going to go ahead and add 4x to both sides. Let's solve this for y. To get it into slope-intercept form, I'm going to keep the x in front, so it's going to be 4x plus 16, and then let's divide everything by 2. So my first equation is 2x plus 8. Now we're going to move over here to our next equation. Let's add 10 to both sides. Let's take a couple more steps. So y equals 2x, actually I'm getting ahead of myself. Y equals 2 times x minus 1 plus 10. Alright, in this case what we're going to do is we need to keep solving this so that we can get it into slope-intercept form. So I actually need to go ahead and distribute my 2. I'm trying to get all this simplified so I can get it into this, like I said, this form right here. So I'm going to have y equals 2x minus 2 and negative 1 is negative 2 plus 10. Now negative 2 plus 10 is 8. So if you look, the 8's match and the 2's match. So these are the same lines. So these are going to be coinciding. Again, what that means is they're the same line. Everything's the same, they're coinciding, which means they're literally laying on top of each other. They would look like one line if you graph them. There's actually two of them just on top of each other. Alright, so those are your three scenarios really if you're dealing with parallel, intersecting, or coinciding lines. Alright, so to wrap up, we have one more, like a problem-solving situation where we need to find, and really we're solving by graphing, a system of equations. So looks like here it's just got Erica's trying to decide between two car rental plans for how many miles will the plans cost the same. So we want to see again when are these going to equal each other. Now the only way you can figure that out is if you have an equation for both, and then you can calculate when they're going to be equal to each other. So we got plan A that is giving you let's call it an initial fee. Now again, this is obviously, I say this a lot, but it's something I talk about in my SAT class all the time. But when you're dealing with finding the equation of a line using a word problem, we're going to talk about the slope-intercept form here. And I'll give you a couple tips that will help you determine which of these values equals what. Which one's a slope, which one's a y-intercept, or so on. So let's start with what we're working on right now. This y-intercept. This is, remember when you plug it in, it's 0b. It's a y-intercept. It's when x is 0. So here's a good way to help you remember what this means in a word problem. It is always an initial. That should ring a bell right here, right? Initial is an initial value. It's where you start. So they're ever giving you a starting value, they're giving you a y-intercept. Whereas m, that's always going to be a rate. Now a rate is, they always use words like per or each. So like $20 per mile or $20 each mile. Now remember, per is a fraction. That's the word you use when you're doing fractions. We said that in the last lesson where it was like, 20 or 200 miles over 3 hours. And we said it was 200, and like I say, you can say it's 200 miles per 3 hours. If we want to word it out, the word per, that is where your fraction's coming from. So using this information, we can jump over here and we can get our equations. The initial fee, these are going to represent your y-intercepts. And look over here, we got a fraction, 35 cents per mile. This is going to represent your slope. So we're going to have two equations, equation A and equation B. So equation A for plan A, that's going to be y equals, and it's going to be plan A, 0.35, that's your slope, x, plus 100 for your initial value. Plan B, not A again, plan B, that's going to be y equals, and it's going to be an initial fee of 85, but your rate is 0.5, so 0.5x plus, in this case, it's your initial fee is going to be 85. So now we have our two equations. Now, in this case, again, they're wanting you to solve this. We can graph it. We can solve using substitution. And I do want to, because we are doing lots of graphing, I do want to talk about how you can actually solve this using the easiest method possible, which is going to be substitution. As you can see, these are both solved for y. If two equations are solved for y, then what I can do is I can take one of those equations and plug it in for y. So I would take this equation in this case, doesn't really matter, but I'm going to take this one, and I'm going to call that y. So I now would have 0.5x plus 85 equals 0.35x plus 100. And I'm going to solve this now for x to see when they're equal. And I'll explain how it looks graphically when we're done. But as you can see, they are going to intersect because they have different slopes. So they're going to touch. So I'm going to solve this for x. I'll subtract 0.35x from both sides. So that's going to be 0.15x plus 85 equals 100. Then I'll subtract 85 from both sides. And I get 0.15x equals 15. Alright, so to help you see this, we could, if you'd like, we could multiply by 100 if you don't like the decimals. And what that's going to do, it's going to move your decimal point over 2 spots. So I can now have 15x equals, and the same thing here, move the decimal point over 2 spots. So it'd be the 2 zeros. So I'd have 1500. If that helps you see things a little bit better. If not, you don't really need to do that. But I'm going to go ahead now and divide by 15. So x equals, and again, if you want to see, okay, 15 goes into 1500, it can go pretty quick. Say 15 goes into 15 one time. And then really we just have 2 zeros coming after this. So you'd have 2 zeros coming after this, and it's going to be 100 for x. So the question is, now that you know that, the question really is going to be this. Actually, let's go ahead before. We'll find y, so I can explain the whole situation. So to find y, let's take either one of our equations. It doesn't matter which one. I'll pick a. And I'm going to plug in 100 for x. So this would be y equals 0.35 times 100 plus 100. So that's going to be 35 plus 100, so 135. So this is your intersection point. Okay, that's where those 2 lines are going to touch. So it says for how many miles will the cost plans, and this is probably worded bad, honestly. Let's go back, and let's fix what that's supposed to say. I wouldn't say for, I'd say after. Because it's not going to be consecutively 100 miles. They're going to be the same. That's just going to be when they actually end up being the same. So they are only going to be the same at one point. Because here's the deal. If I was graphing these lines, you're going to get 2 lines that look like this. And they're going to touch at this one point. It's only going to happen once. So as we're graphing this, we want to see what was the x value. Well, the x value is, you're going to plug in, it looks like it's 0.535 cents per mile. So this is going to represent our miles. Because it was 35 cents a mile, 50 cents a mile. We plug in the number of miles, because that's what we're multiplying by our 0.5 or 0.35. The output, though, is going to be money. So what you'd say is, after 100 miles, you would say both plans would cost $135. So again, if you're looking at these plans, Plan A, you start at $85. Or sorry, Plan B, you start at $85. So if you're not going to be going 100 miles, then you probably want to go with Plan B, because it's cheaper up until that point. However, Plan A, it starts at a higher rate, or a higher initial value, but the rate is lower. So once they hit 100 miles, then this one's going to, see how it starts higher. Probably the line should look something like that. Let me try to fix that. Oops, I didn't mean to erase all those things. Yeah, that's 135. Okay. So if you look at these 2 plans, this would probably be Plan B, because it started lower, and then Plan A. So Plan A is more expensive. I'm right down here at my graph. Be more expensive, then they touch, and then it becomes less expensive. So again, it just depends. They're not asking you which one would you want if you're going 400 miles, but if they were, I'd be picking Plan A. Or if they were going 4 miles, I'd pick Plan B. Alright. So we got a lesson quiz. We got 2 parts here. So I'll leave that up so you can pause it for part 1. And we'll go over to part 2. And I can pause it. Again, there's 4 questions. It looks like there's 2 slides, but again, if you know some of these questions we went through, and they can go pretty quick if you know what you're doing. And we got your reflection. Alright, so go ahead and work on those, and I'll see you guys in class.